Okay, so let us now discuss question number 28 from the practice sheet. Question number 28 says, in given figure P, P dash and Q, Q dash are two non-parallel common tangents of the two circles. Show that P, P dash is equals to Q, Q dash. Okay, so it simply says that there is a circle, there are two circles. Question number 28. Let us first draw two circles. Let us say this is the first circle, and you can see in the diagram the other circle is intersecting this circle like this. Okay, so these two circles are intersecting each other at two different points. Now, then it says that P, P dash and Q, Q dash are two non-parallel common tangents. So what is meant by non-parallel common tangents? First, what is common tangent? You can see that P, P dash is a tangent to the circle with center O at point P, and the same line, the same P, P dash is also tangent to the circle with center O dash. It is tangent to both the circles. It is tangent to both the circles. OO, this with center O and with O dash. And this is tangent to this circle with center O dash at point P dash. Similarly, QQ dash is also a tangent which is common to both the circles. It means QQ dash is tangent to this circle at point Q and tangent to this circle at point Q dash. Okay, so this is the figure, and it says that these two tangents are non-parallel. If two lines are non-parallel, I can say that the two lines will going to intersect each other at some point. You can see this line will go like this and this line will go like this, and they will intersect at a single point. So what we will going to do is, let us produce this line like this, and let us produce this line also. So they will intersect somewhere here. Okay, you can see the span is very large. It is intersecting at this point. This is, let us say, point A. Let us suppose this is the point A at which both the lines are, both the tangents are intersecting. Now we need to prove that PP dash is equal to QQ dash. That PP dash is equal to QQ dash. So how will we prove this condition that PP dash and QQ dash are equal? We can see that A is an external point for both the circles. I can see if for a minute, if I forget about this circle, the circle with center O dash, I can see that from a point A, I have drawn two tangents AP and AQ to this circle. Okay, A point से मुझे दिख रहा है कि AP और AQ दो tangents हैं इस particular circle के लिए. I can say, since A is an external point to the circle with center O, for this circle, if A is an external point, I can say that AP is equals to AQ. Why? By theorem 2. By theorem 2, I can say AP is equal to AQ. This is what we have learned in theorem 2. Okay. Now, let us say this is our first condition. Similarly, if you forget about this circle, I can see that A is an external point for this circle also, which is circle with center O dash. I can write since A is an external point to the circle with center O dash. O dash वाले circle के लिए भी A point is an external point. So what you can see is I can very easily write that A P dash is equals to A Q dash, again by theorem 2. Let us say this is the second condition. A P dash is equals to A Q dash. Now observe very carefully what is AP and what is AQ. You can see the length AP is basically sum of two different lengths. The first length is AP dash and second length is P dash P. So in place of AP I can write, so from equation 1 I can write AP dash plus PP dash is equals to, and in place of AQ I can write AQ dash plus Q dash. Can I write this condition? In place of AP I have written AP dash plus PP dash is equal to, in place of AQ I have written AQ dash plus Q dash. Okay. Now in this condition you can see that AP dash and AQ dash, this one and this one are equal. AP dash is equal to AQ dash. So from equation 2 I can say that I can cancel this AP dash and AQ dash, and finally I will be left with PP dash is equals to QQ dash. So this is the proof. Okay, you can see this question is very simple. It's just the application of theorem 2 two times. I have applied theorem 2 here and also here, and just analyze both the conditions, and by simple arithmetic I can write PP dash is equals to QQ dash, because AP is the line segment which is made by two different line segments, AP dash and PP dash. AQ is the line segment which is the sum of two line segments, AQ dash and QQ dash. So from that I can get a PP dash is equals to QQ dash. Okay. So this is the solution for question number 28. So you can note this, then we will continue. Okay, so let us now discuss question number 29 from the practice sheet. Question number 29 says, if A, B, C are the sides of a triangle, of a right triangle, where C is the hypotenuse, prove that the radius R of the circle which touches the sides of the triangle is given by R is equals to A plus B minus C upon 2. Okay, so this question says that there is a right angled triangle, there is a right triangle. So question number 29, right triangle. First let us draw a right triangle like this. There is a right triangle, and in this right triangle A, B and C are the sides of this triangle, and there is a condition given that C is the hypotenuse. So it means this side is C. Okay, this side is C. Now this side is C, so this vertex, I will say this vertex is capital C. Okay, because ऐसा होता है triangle में. For example, there is a triangle ABC. So let us draw a triangle. If I say that this is a triangle ABC, so A vertex के सामने वाली जो side होती है, this is small a. Okay, B vertex के सामने वाली side को हम small b कहते हैं, और C vertex के सामने वाली side को हम small c कहते हैं. So just in this manner I can say if this is small c, this will be capital C. And what about A and B? I can mark A and B anywhere. So let us say this is A. This side is A. The length of this side is A. So what will be this vertex? This vertex will be capital A. Okay. and if this side is B, then this vertex will be capital B. This is a convention that we use in triangle. जो vertex है उसके सामने वाली side, that will be the smaller case, the lower case of vertex. If this is A, then lower case of this capital A is this side. The length of this side is denoted by lower case of this vertex. Okay. So opposite vertex and side, this is a condition, this is a representation that we use in triangles. So this is the diagram. Now it says, prove that the radius r of the circle which touches the sides of the triangle. Okay, so there is a circle which touches the sides of this triangle. It means this circle is definitely inscribed inside this triangle. So let us say this is the circle. Okay, let us approximate that this is a circle. Now the radius of this circle, this is the center, so the radius of this circle r, we need to prove that r is equals to a plus b minus c divided by 2. That is, we need to determine a relation between the sides of the triangle and the radius of this circle. We need to relate these two particular things. Okay, so let us think how to relate this radius and the sides of the triangle. You can see that if I join this center with this point, this is the point where this circle touches AB side. Okay, let us say this point is F. Okay, let us say the circle touches this BC point, this BC line at E. Okay, and let us say the length of this side is B, and the circle touches this AC side at point D. So D, E and F are, let us say, the points where the circle touches three sides of the triangle. Okay, now if I join this center with this F point, if I join this center with this F point, I can see F, this, let us say O is the center. I can see that OF is a perpendicular to this particular tangent. Okay, because I can see that AFB is basically a tangent to this circle, because this circle touches this AFB at point F. So this particular angle will be 90 degree by theorem 1. Similarly, if I join, let us draw this D point, let us draw this circle like this. Okay, and here also like this. Now this is the point E and this is the point D. So similarly, if I join this O point with this D point, OD is the radius and ADC is the tangent to this circle, then this angle will be 90 degrees. I can see that OD is radius and this ADC is tangent. Therefore, I can write OD is perpendicular to ADC. Okay, so this angle is 90 degree. Similarly, if I join OE, you can see that OE is the radius of this circle, that is, the radius is R, radius of this circle, and this CEB is a tangent, okay, to this circle. So definitely this angle is also 90 degree, again by theorem 1. Now this angle is 90, this angle is 90, and this angle is also 90. It is given that this is a right angle triangle. So if you observe quadrilateral ODCE. If you observe quadrilateral ODCE, you can see angle ODC is equals to angle DCE is equals to angle CEO is equals to 90 degree. So these three angles are 90 degree. So what about this angle? This angle has to be 90 degree because the sum of internal angles of a quadrilateral is equal to 360 degrees. So definitely this angle is 90 degree. So all the angles inside this quadrilateral, the internal angles of this quadrilateral are 90 degree. So what does this mean? This implies, so since all angles of quadrilateral are 90 degree, this implies ODCE is a rectangle. ODCE क्या है? ODCE एक रेक्टेंगल है बिकॉज सारे एंगल्स 90 डिग्री हैं. लेकिन एक कंडीशन और दिखाई देती है. आई कैन वेरी क्लियरली सी दैट OD is equals to OE. Why OD and OE are equal? Because both are radius of the circle. Both are radius of the circle, and OD and OE are adjacent sides of this quadrilateral. So if all the angles in a quadrilateral are 90 degree and adjacent sides are equal, I can say ODCE is a square. I can say that ODCE क्या है? एक स्क्वायर है. स्क्वायर कैसे प्रूफ करा? हमने सबसे पहले इसे एक रेक्टेंगल प्रूफ करा बिकॉज सारे एंगल्स को 90 डिग्री बताया. देन वी सेड कि ये वाली साइड और ये वाली साइड जो कि एडजेसेंट साइड्स हैं, these two sides are equal because they are radius of the circle. That's why I have said in a rectangle in which adjacent sides are equal is basically a square. So ODCE is a square. Now what you can observe is, you can see that if you observe this OE length, OE is basically equal to DC. Since ODCE is a square, so I can write OE is equals to DC. Now what is DC? DC is AC minus AD. DC की जगह हम लिख सकते हैं OE is equals to AD minus this AC minus AD. Okay, this OE length is DC, and in place of DC this is AC minus AD. Now what is OE? OE is the radius of the circle, so I can write in place of OE I can write R is equals to AC minus AD. But you can see A is an external point for this circle. Okay, and from A I have drawn two tangents AF and AD to this circle. Since A is an external point and two tangents are drawn from this point, I can say the length of tangents are equal. What I can say is A is an external point and AD and AF are tangents to the circle. It implies AD is equals to AF. Okay, AD and AF are equal. So in this condition, in place of AD, can I write AF? I can write it R is equals to AC minus AF. Now what is AC? AC is this length and this length is B. So in place of AC I can write B. So R will be equals to B minus AF. This is one condition. Okay, this is one condition. Now observe OD. You can see that OD is equals to CE. OD and CE both are equal because this is a square. So OD is equals to C E. Now what is CE? CE is this length. CE is basically BC and minus BE. In place of CE and in place of OD, OD is radius R is equals to BC minus BE. Now what is BC? BC is small a. So in place of BC I can write R is equals to BC A minus now BE. What is BE? You can see that B is again an external point from this to this circle, and from B I have drawn two tangents, one is BE and another is BF. So BE is equals to BF. So in place of BE I can write BF, since BE is equals to BF. So this is R. R is A minus BF. Now what we simply need to do is, what I have done is, I have tried to determine a relation between radius and the sides of the circle, and we have related the sides of the triangle, and we have related the triangle and the radius using this particular square. From this square I have determined two relations. Now just add these two relations. If you add these two relations, you will get, so add, this is let us say first, this is let us say second, add 1 and 2, you will get R plus R is 2R is equals to A plus B minus BF plus AF. Okay. Now what is BF plus AF? BF and this is AF. BF plus AF is AB. So in place of, so this is 2R is equals to A plus B minus AB. Now what is AB? AB is equal to C. The length of AB is small c. So I can write 2R is equals to A plus B minus small c, which implies R is equals to A plus B minus C upon 2. Okay. So this is what we need to prove. So hence proved. This is the condition that we have proved. Okay. So this is the solution, this is the proof for question number 29. First note this and then we will continue. Okay, let us now discuss the next question, that is question number 30 from the practice sheet. Question number 30 says, in given figure, from an external point P, a tangent PT and a line segment PAB is drawn to a circle with center O. Okay. ON is perpendicular to the chord AB. Prove that the first PA into PB is equals to PN square minus AN square. Second, PN square minus AN square is equals to OP square minus OT square. Third, PA into PB is equals to PT square. Okay. So this question says that in a given figure, you can see the given figure. The figure is something like this. This is the circle, and this PT, there is a point P outside the circle, and this PT is a tangent to the circle, and there is a line segment like this which touches the circle at point A and another at point B, and then you can see this is the center O of the circle, and this is the line. It says that ON is perpendicular to chord AB, so this is N. Now you can see ON is a radius. No, it's not a radius, it's a line drawn from the center of the circle to this particular chord, and this line is ON is perpendicular to this chord AB. Now just observe this perpendicular drawn from the center to a chord. What is the property if I draw a perpendicular from center to this chord? The property is perpendicular drawn from center to a chord bisects the chord. The property says that perpendicular drawn from the center to a chord bisects the chord. It means this ON bisects this AB chord. Okay, ON bisects the chord AB. So I can write AN is equals to BN. This is the condition, that AN is equals to BN. I can simply observe this condition from this diagram. Okay. So now till this we have just drawn the diagram and we have tried to understand the diagram. It says that this PT is basically a tangent to this circle and this is OT. So this PT is tangent, OT is radius, this angle is 90 degree, this angle is equals to 90 degree, and we have also this O and P joined. Okay, this external point P is joined to this point O. So now this is the interpretation of the given conditions. Now it says prove that. So we need to prove. First thing that you need to prove is PA into PB is equals to PN square minus AN square. Now what is PA? PA is this line. Okay, PA is this line. I can see that in the LHS I have PA and PB, and in RHS I have PN and AN. What is PN? PN is this line. Okay, this particular line. So it means, it implies that I have to convert this PA and PB in terms of PN and AN. Okay, let me repeat this. I am saying that in LHS I have PA and PB, and in RHS I have PN square and AN square. It means I have to convert this PA and PB in terms of PN and AN. Okay, so let us analyze LHS of this question. LHS is PA into PB. What is PA? PA, can I write this PA in terms of PN and AN? Yes, it's very easy. I can see that this particular line PA is equals to PN, this particular PN minus this AN. Okay, in place of PA I can write PN minus AN. Okay, PN minus AN into, and in what about PB? I can see that PB length can be written in terms of PN also. I can write PB is PN plus NB. Okay, PN plus NB. I can write PN NB or BN. Okay, let us write it as BN. This is BN. So PN minus AN into PN plus BN. But we have this condition that AN and BN are equal. Why? Because ON is a perpendicular to this AB chord and it bisects this particular chord. So I can write, since AN is equals to BN, it implies PN minus AN into, in place of BN I can write this AN. So it will become PN plus BN. Now this is A minus B and A plus B. Pn minus An and Pn plus Bn. So I can write this as Pn square minus An square, and this is what RHS is. Okay. So hence proved from this condition, this Pn square minus An square, it is RHS. So this is the proof for the first condition. The second condition that we need to prove is Pn square minus An square is equals to OP square minus OT square. Now you can see I need to convert this Pn square in terms of OP square and this OT square. Okay, OP square and OT square, and then this is An square, this is An. So what about An? Can I write An in terms of some different value? Let us try to analyze this, let us try to understand this. Okay, what I can see is this Pn square, if you observe triangle OPN, in triangle OPN you have OP square is equals to ON square plus Pn square. It implies Pn square is what? It is OP square minus ON square. So Pn square की जगह पे हम OP square minus ON square लिख सकते हैं. So analyze this LHS. LHS is Pn square minus An square. In place of Pn, I can write OP square minus ON square. This is OP square minus ON square and minus An square as it is. Okay. Now this is OP square minus to the bracket ON square plus An square. I can write it as like this. OP square, I have got the term OP square. Now I just need term OT square. So what I have done is I have taken this two in bracket, this ON square and An square. So ON square plus An square यहाँ पर आ गया है. Now can you analyze what is ON square plus An square? ON square is this, and what is An square? It is this. So if you draw a line from this O to this A, you can see triangle ONA is a right angled triangle, right angled at point N. What you can see is triangle OAN is a right angled triangle. So triangle OAN is a right angled triangle. In this triangle I can see OA square is equals to ON square plus An square. So in place of ON square plus An square I can write OA square. So what you will get is this particular is equals to OP square. So this is LHS is equals to OP square minus, in place of ON square plus An square I have written OA square. So LHS is OP square minus OA square. Now but I want OT square. I want OT square. I do not want OA square. But you can see OA is the radius, OT is also the radius. So can I say OA and OT are equal? OA is equals to OT is equals to radius. Okay. So in place of OA I can write OT. So this is OP square minus OT square, and you can see this is basically the RHS. Okay. So this is proved that Pn square minus An square is equals to OP square minus OT square. What we have done is we have just analyzed the triangle, the given triangle, and from that triangle we have applied the Pythagoras theorem, and just by applying the Pythagoras theorem we have got this condition. Okay. The thought process for this question is, you can see there are squares, Pn square, An square, OP square. So try to think that since there is a triangle and there are tangents and there are perpendiculars, so there might be something application of hypotenuse theorem, Pythagoras theorem. So by application of Pythagoras theorem and concepts of circles, we have determined this condition. Okay, the concept of circle is that this ON is perpendicular to AB, so AN is equals to BN. Okay, so this is the second proof. Then the third one is, third condition that we need to prove is PA into PB is equals to PT square. Okay, so this is PA, this is PB, it is equals to PT square. Now try to observe this condition. I have PA into PB is equals to PN square minus AN square. This is what we have already proved. After this, PN square minus AN square is proved as OP square minus OT square. So can I say from first and second conditions, I can write in place of PA into PB, let us try to analyze the LHS. LHS is PA into PB. In place of PA into PB, I can write PN square minus AN square, and in place of PN square minus AN square, I can write OP square minus OT square. So what I can say is PA into PB is equal to OP square minus OT square. Okay, OP square minus OT square. Now what is OP square minus OT square? You can observe triangle OPT. In this triangle, this is right angled at, it is right angled at this angle. This is T is 90 degree. So I can write OP square is equals to OT square plus PT square. So it implies that OP square minus OT square is equals to PT square. Now in place of OP square minus OT square, I can write PT square. So you will get LHS is equals to PA into PB is equals to OP square minus OT square, and this is equals to this is equals to PT square, which is the RHS. Okay, this is the proof for third condition. This is the proof for third condition. So in this manner we need to solve this question. This question is very interesting question and as well as very important question, because this question contains lots of concepts, the application of concepts of Pythagoras theorem, circles, okay, and a bit of analysis that you need. So this is the question number 30. Okay, so you can note this question.